Welcome to Senior Informatica. Today topic is conversion of non-deterministic finite automata to deterministic finite automata. That means we are going to be converting the NFA automata to equivalent deterministic finite automata. Right? For this, we are going to be defining the two machines. One machine for the NFA and one machine for the DFA. Let M equal to phi tuple Q comma sigma comma delta comma Q naught comma F be an NFA. That is, we define the NFA machine. Now we have to construct the equivalent DFA. For that purpose, I consider M dash. In that, we have the phi tuples Q dash, sigma dash, delta dash, Q naught, and F dash, where Q dash is equal to 2 power Q. That is a power set of states. The states denotes in Q dash will like this: Q1, Q2, Q3, and so on up to Qj, which is a single state in Q1. It will be represented as a single state in Q1 and several states in Q. Whereas coming to the Q is a representation of NFA state, Q dash is a representation of DFA state. So in the Q we have the several states, but whereas in the Q dash it is considered as a single state. Sigma is an input alphabet or symbols. But coming to the delta dash is a transition mapping from Q dash into sigma tends to Q dash. That is, by considering one set or set states or single state with some input, it reaches to the Q dash state. It is denoted as delta dash of Q naught comma X is equal to, it gives the Q naught, Q1, Q2 and so on up to Qj. If delta dash of Q naught comma X equal to set of Q1, Q2, Q3 and Qj. Clear? I think here it is not Q. The initial state of an NFA becomes an initial state of DFA. Clear? F dash is a set of states of 2 power Q which contains one element of F. It may have the 2 power, the set contains the final set contains the two states, then it will be having the contains the one element of F. Like this, we are defining the machine M and machine M dash. That is NFA and DFA machines. Now consider one example. Let us see how it is going to be happening. Here I considered that one DFA quotient, DFA equivalent to NFA. In that the machine contains the phi tuples. According to the transition table, this is the transition table. In that we have the two states and two inputs. So two states are Q0 and Q1. In Q, it is a capital Q. This is the sigma input symbol or alphabet. This is a transition initial state and this is a final state. According to the table, transition table, Q0 contains the arrow mark that indicates that it is an initial. In the table it contains the circle, is indicates that final state. By considering this NFA table, we are going to constructing the equivalent DFA, right? Here we have to draw the NFA table. Already it is given in the question. Now we have to draw the NDFA transition table. How we have to draw? By considering Q naught. Q naught is the initial state for Q naught for NFA as well as for the DFA. So we are starting with the Q naught. At the state of Q naught, we are going to read the input value 0. Right? It moves to the state. It moves to the state Q naught and Q1. Clear? It's moving the state. Q naught is moving the state by reading 0 to Q naught comma Q1. Clear? It will be represented in the DFA transition table also. For that, before that, we have to write the transitions delta dash. That means delta dash is indicated in the represented in the DFA. So delta dash of Q naught comma 0 equal to delta of Q naught comma 0 equal to set 0 comma 0 set comma 0 comma Q1. This is the representation of NFA. Okay, this is the representation of DFA. Now we will write the transitions in the table. Right, in the state of Q naught, by reading 0, we are reaching to the state Q naught comma Q1. It is going to be placed here. Right. Next, we will read the Q naught on 1. Q naught on 1 is reaching to the state Q1. Now we have to write the transition table, transitions for the DFA. Delta dash of Q naught comma 1 equal to delta of curly braces Q naught comma 1 equal to Q1 in the square braces Q1. So now it has to be represented in transition table of DFA. Right? We got the Q1. Q1 is represented in transition table here. Now observe that at the state of Q naught on reading 0, we obtained state is Q naught comma Q1. On Q1, Q naught on 1, the obtained state is Q1. Now we are going to considering these two states. So first I am going to take in the single set of state, that is Q1. So now we have to write the delta dash of Q1 on 0 moving to the state 5. So delta dash of Q1 comma 0 equal to delta dash of curly braces Q1 on 0 reaching to the state 5. Clear? Now it has to be represented in DFA table. In the DFA table, we will get Q1 on 0, 5. Next, we have to read the Q1 on 1. It's moving to the state Q0 comma Q1. So the transition will be like this for the DFA. Delta dash of Q1 comma 1 equal to Q1 on 1 equal to Q0 comma Q1. This is reaching the state Q1 comma Q1. So it has to be reflected in the DFA transition table. Clear? Now there is no use of DFA. Why means similarly DFA is built in. So by using this DFA NFA DFA table, we can go with the Q0 on Q0 Q1 here. The set contains the Q0 comma Q1 will be taken from DFA table. So next state is Q0 comma Q1. Next is q0 comma q1 on 0. We write the delta of q0 comma 0 union delta of q1 comma 0. We can observe that on q1 on 0 q1 on 0 we are moving to the state q0 comma q1. Next q1 on 0 moving to the state 5. Now we are going to apply in the union. Again you are going to get the q0 comma q1. So delta of q0 comma q1 equal to on 0 will gives the q0 comma q1. Next q0 on 1 q1 on 1 doing the union, that is these two q1 union q0 comma q1 union. Again you are going to get the q0 comma q1. So here we place the q0 comma q1 here. Okay, now we have to define the DFA machine, that is m dash equal to q0 dash comma sigma dash comma delta dash comma q0 comma f dash, where q dash equal to we got the set of states. We got the q0 q1 q0 comma q1 states they are representing here. The inputs is same as a NFA, so 0 comma 1. Already we see in the transitions table, transitions shown in the above. Based on the transition we got this transition table. The initial state of NFA will become the initial state of DFA. So the q0 is a initial state. Now coming to the final state, how we are going to take in the final states means, as per the NFA table, q1 is a final state. In the table wherever we have the q1 combination with any other state, it will be considered as a final state. So q0 comma q1 is a final state. So the final states are two here, that is q1 comma q0 comma q1. After defining the machine, we have to draw the transition diagram by taking the input of transition table. Here we have the three states, so we have to consider the three states. q0 is initial state, so keep a arrow mark here and write start. Next create a q1 state, create a q0 comma q2 state. q1 and q0 comma q1 are the final states, so it should be double circle. Now we have to draw the transitions between the states. The initial state is q0, so q0 on 0 moving to the state q0 comma q1. So we have to draw the transition between q0 and q0 comma q1 states. That means these two states with input symbol 0. Next we have to draw the transition q0 on 1 moving to the state q1. So we have to draw the transition between q0 and q1 with input 1. Next coming to the q1 state, q1 on 0 5 is not a state, empty, leave it. q1 on 1 moving to the state q0 comma q1. So we have to draw the transition between q1 and q0 comma q1 with input symbol 1. Next q0 comma q1 on 0 moving to the state q0 comma q1, same state. So we are going to draw the itself loop for the q0 comma q1 with input 0. Clear? Next, we will draw the transition on q0 comma q1 on 1. q0 comma q1 on 1. It is moving to the state q0 comma q1. Again, it is a itself loop. So in the itself loop, we will have the 0 as well as 1. Here, this is called the transition table. This is called the transition diagram, or you can say that transition system of DFA. This is how we created or constructed the DFA from NFA. I hope that you understand the concept of conversion of equivalent DFA. Thank you.